Today we're going to be doing a lab called Intermolecular Forces. So the first page is really a cover page, but there is some work to be done. So the first two things you're going to do is define intermolecular force and chemical bonds. And then in question one, I want you to tell me the difference between the two, because that is a very often confused topic. The difference between a chemical bond and an intermolecular force. Students often think they are one and the same, or one is the other. And so we'll go through it and explain it a little bit more as I do the first example problem, but I do want you to look those up and then in your own words explain the difference. So you're going to be drawing out molecules, and they're going to look like this. So we've got our H2O, our HBr, and these are our nonpolar molecules. These guys are our polars. That's why they have the polarity arrows to show the positive and negative end. I've got a color code here, so it shows you how to color them. I colored them in for you, at least for this first one. You're going to be coloring these in as well, so the front page of your lab should be colored, as should your entire lab. Hydrogen atoms are going to be yellow, oxygens are red, sodiums are purple, halogens, which is from F straight down, are green. Intermolecular forces are going to be a red dashed line. There are none pictured here. Once you actually put multiple molecules together and show how they attract to each other, that's the actual intermolecular force. And then chemical bonds are in the blue. All right, so that's the basics for the beginning of the lab. And now let's get to the scenarios. So in diagram one, what you're going to do is you're going to draw 3 water molecules and show how they attract to the Cl minus. I put the 1 in, you could too if you want, or Na plus. You're going to show how they attract there. So I'm going to do this one first. I'll do one example problem and that's it. So you're going to draw them out just like they were on the first page. They're going to look like this. Obviously yours are going to be colored. You're going to have polarity arrows as well, just like I do. And they point towards the negative and away from the positive. And then the intermolecular force, so this part in the middle, this is the chemical bond, it'll be blue, just like the lab or the front page. The intermolecular force is the dashed red line, and it's the attraction. So all it really is an attraction from one molecule to a different molecule. That's why it's called intermolecular force. Like an interstate highway is a road that runs between two states. A road that stays within the same state is technically called an intrastate highway, or something like that. Although I think we never really actually use those terms. So that's really the difference. Whereas a chemical bond is between two different atoms inside of a molecule, and they're also, while they all share the fact that opposites attract, they are done slightly differently. And so you should know your different chemical bonds, and now the results of polarity cause intermolecular forces of attraction seen here. So on chlorine, so this is one molecule. You're going to draw 2 more for chlorine. You're going to show which end of the water attracts to that. So for number 2, you're going to draw 6 HBr molecules, and you're going to show how they attract between each other. So in other words, you have one HBr molecule, and then you're going to show how it attracts to a different HBr molecule. There are no rules for drawing them out. Like, they don't have to be a straight line. You could do any pattern you want as long as you have opposites attracting. That's the only thing that has to be done. And you see where it says assign partial charge? I show it on all of them. Well, that's what this arrow is showing. So the polarity arrow is the partial charge. It's showing you that the oxygen here is partially negative, therefore the H side is partially positive, and that's how I know that the O of this molecule attracts to the Na of that molecule, because the negative will attract to the positive. So the assigning partial charge, that's a fancy term for drawing the polarity arrows. Use the dashed red line to show the intermolecular forces, that's that. And then in this case, step 1 is draw the 6 HBRs any way you want, as long as opposites attract. That's the only rule you have to follow. Next. So we've got diagram 3 is hydrogen bonding. So in this one, you're just going to draw 6 water molecules and show how they attract to each other. This is the same as the intermolecular force one, which is diagram 2. The only difference is, because it is FO or N bonding to H, we call it hydrogen bonding for the intermolecular force, whereas when it's not FO or N and it's just some random polar molecule that doesn't have this scenario, it's called dipole forces, but it's really the same thing. So you're going to draw 6 water molecules, show how they attract to each other with the dashed red line, show the partial charges by adding the polarity arrows, and you're going to put it all in this box again. No pattern is wrong. There's no right way of drawing it. As long as you have opposite charges attracting between different molecules, you'll be right every time. And then the last one, London dispersion forces. So what this is showing how non-polar molecules attract. So if you remember from the beginning of the lab, I had you draw out. So this is one H2 molecule. So this is one H2, and this is obviously one F2 and one Cl2, and that's 1I2. So these are one of them. What you're going to do in diagram 4 is draw 2 of each and show how they attract. Now, I'll do the first set because that one tends to throw everybody off. If you noticed, I made the molecules get larger the heavier they got. So the smallest molecule would be H2. So I'm going to draw it as small as I can. And then if I were going to draw another H2, since they're really small and they don't attract a lot, I could put it all the way over here. And then I would just show the attraction. And what's going on is the protons of one, obviously I made this thing really far apart to overemphasize this. The protons of one attract to the electrons in the bond of the other, and the same thing is true there. Now, as the atoms get bigger, we're going to make them larger, because they are in fact larger, and their attraction is going to get greater, so the pairs will get closer together. So if I were to draw the F2 pair, it's going to be slightly larger. Now you may have to resize this to make everything fit, or you can put it on a separate sheet of paper. So I physically made the molecule bigger, and then they are going to be closer together. Now, if you're not sure what's going on or why I'm doing this, go back to my notes on intermolecular forces, and I actually have a diagram where I show you exactly how 2 H's will attract to each other. So it turns out the protons of one attract to the electrons of the other, and that makes them attract, and the bigger the molecules get, the more protons, therefore the more positive they are, and the more electrons and more negative they are, so their attraction gets greater, the molecules get closer together, and so that's what you're going to do as you go from H2 to F2 to Br2, Cl to Br to I. When you get to I, the molecules are basically going to be touching. Cl and Br are going to be very close together, and then H2 and F2 are still going to be very far apart, and the reason is very simple. At STP, these are gases, liquid, and that one's a solid. So that's the intermolecular forces of attraction is what's causing this change by making the molecules attract harder. They get closer. As they get closer, their phase changes. And so that's diagrams 1 through 4. And then the last bit is going to be to explain it all. In other words, in diagram 1, you're going to explain why the oxygen end of the water attracted to one of the positive or negative ion, and then you're going to say why the other side attract to the other ion. In diagram 2, you're going to explain it in your words. Why did the H of one attract to the Br of the other? The same for diagram 3, the same for diagram 4. Number 5 is just a review question. What 3 compounds contain hydrogen bonding? You should know the statement by now. Question 6, what is a hydrated ion? I will give you a hint. It is, which diagram? Diagram 1 is a hydrated ion. I want you to still explain it. Number 7, what forces of attraction occur between nonpolar molecules? That is diagram 4. Number 8, based on diagram 4, what determines the strength of London dispersion forces? And you're going to answer all these questions, which is a lot to know, but it's really important. It's also, if you can answer 8, you can answer 7. And number 9, one of my favorite questions, in terms of intermolecular forces, what's the difference between CO2 and H2o? Which one will have a higher boiling point? Well, that's really easy. The hint here, and this is something that you really should do, you have to draw the molecules, because if you draw them out properly, you'll find that CO2 and H2o, while very similar, they both have 3 atoms. One of them is going to be linear with double bonds, the other is going to be bent with single bonds, and then that difference in shape will cause them to have different intermolecular forces, and intermolecular forces are what cause boiling points to change. And so whichever one has the stronger intermolecular force will have a higher boiling point. Whichever one has the lower intermolecular force will have a lower boiling point. So that's everything you're going to need to know for this lab.